Okay, today we're going to talk a little bit more about rate of change. We can be given a graph. We talked about the fact that rate of change is really the same as the slope of our line between 2 points. So in this particular case, since we're given a graph, we're going to go ahead and figure out the rate of change between 2 points, 2 given points on this graph. So I'm going to pick 2 points. My first point is going to be right here. And if I were to see the order pair for that, this is going to be -3, -4. Because we would just count over -3 and -4 down, plus we can see the numbers that are there on the graph. The second point I'm going to look at is right here. And the order pair for this is going to be 1, 1. All right, so now that I have my 2 order pairs, I just need to try to figure out what is my rate of change between those 2 points. So we have a formula that we need to make sure we're remembering. It's going to be y2 minus y1 over x2 minus x1. There's a couple ways you might see this set as well. You can talk about it being the change. You can call it the change in y over the change in x. That triangle just means change. And you might also just see the difference between. So the difference in our y's over the difference in our x's. Now the hard part about this is to make sure that you keep with the same x1, y1, and x2, y2 as you do this. So what I like to do is I'll actually write out my order pair as we did, and then I'm going to label them. It doesn't matter which pair I call 1 and which pair I call 2, as long as I keep it the same each time. So this first one right here, I'm going to call this one my x1, and then this makes this my y1. So that makes my 1's over here. This one is going to be my x2 and my y2. All right, now that I have that, that's going to help me out now for putting my answers in here. So I'm just going to substitute. My y2 is right here. There's one reason why I like to do it like this. I can sort of circle what I'm doing. So I have 1 minus, because I'm subtracting now my y1, which is right here, and I'm subtracting a -4. Which we need to remember then to clean up my double signs here. This is going to be adding the opposite, or I can just change that double sign to a positive, whichever one I want to do. But nonetheless, it becomes 1 plus 4. Now my x2 is right here. I have 1, and I'm subtracting from it my x1, which is -3. So again, this becomes adding the opposite. So I have 1 plus 4 and 1 plus 3. When I do the math here, I wind up with 5 over 4, which is then my rate of change for this. We can also change this, though, to be 1 and 1/2, or 1.5. Oh, I'm sorry, 1.25. Because it's 2/4. All right, so let's take a look, though, at this part here, because we did talk about the fact that my rate of change is the same as the slope of the line. So if I start from this point down here, let me do it in red. If I start from this point down here, I should be able to count up 5 and over 4 and get to this point here. So I'm going to go up 5, 1, 2, 3, 4, 5, and over 4 to the right, 1, 2, 3, 4, and look at that, I do. So right there, this was my rise over run. So the rate of change matches the slope, which is what we're looking for. So my rate of change, though, is actually going to be in decimal form in this case. 1.25 is my rate of change for this one. A couple of things to keep in mind, too. We can clearly see it's a positive slope because it goes from the lower left to the upper right. So that's a positive slope as opposed to a negative slope. And we know we have a positive answer for our rate of change. Let's do another one. Just from looking at this, we should know that our answer for our rate of change is going to be what? If you said negative, you're correct, and that's what we need to do here. I'm actually going to let you now solve this one, and then I'll work it out, but you're going to solve it and then do your answer for the Edmodo question. we're going from this point right here to this point right here. So you want to go ahead and solve it using your formula and get the rate of change between those 2 points. Okay, again, let me get my, this is how we're going to, this is how you should have solved it, excuse me. My first point, I'm going to use the one that is negative 1, 2, 3. So it's negative 3, positive 1, 2, 3. My second point that I have is 0, because I did not go right or left, and 1. Okay, so that's my, again, this is going to be my x1 and my y1. This is going to be my x2 and my y2. It doesn't matter which one I use. If I use the other way around, that's okay. If you called negative 3, 3 as your x2 and y2, that's okay, as long as you keep it the same throughout your problem. Our formula again, y2 minus y1. Remember, you do want to remember this formula. You want to memorize it because you're not going to see it on given to you in anywhere. You have to make sure you remember how to do it. So the change in y over the change in x, or the difference between the two. So it's x2 minus x1 for the bottom. Okay, now I'm going to go and plug in my numbers. So for my y2, I have 1 minus my y1 is 3. My x2 is 0. And my x1 is negative 3. Here we go again with the negative, negative. Remember, I can circle these and then they become positive. So if you do it that way, that's fine. Or like I said before on the previous example, you can just say add the opposite. Okay, so now let's go and do our math. What is 1 minus 3? We get negative 2. And 0 plus 3 is 3. So my answer here is negative 2 over 3. In this case, if I were going to change that to a decimal for my actual rate of change, then it would be 0.666 repeating, or negative 0.666 repeating. But I'm going to leave it like this for now, because now I'm also going to double check to make sure that this is true with my rate of change. Because again, this rate of change here is also the same as my slope. So I should be able to go over here to my graph, and instead of rise over run, it's going to be fall because it's a negative 2. So I'm going to see from this point right here, can I go down 2 and go over 3? And I can, and I'm right there on that same point. So again, I found that not only do I have my rate of change, but I proved it with my slope to make sure that my that is correct, that they both match. Okay, if they just give me 2 points like this, no graph, no nothing, I'm going to do the exact same thing. I should not freak out if I see this. So I'll work out this one with you, and then you'll do the second one as part of your question there. So again, I can name either one of these as my x1 and y1. I'm going to do the first one. I tend to keep with the order they give it to me. So my x1, y1, and then this is going to be x2, y2. Okay, so I'm going to use my same formula. I have y2 minus y1 over x2 minus x1. When I plug in my numbers, I get 3 minus a negative 1. Again, double sign, so I'm going to add the opposite. x2 is negative 2 minus x1 is 4. All right, so that becomes 4 over, what's my answer for the denominator here? If you said negative 6, you are correct, because it was negative 2 minus 4, which means add the opposite if you want to think of it that way. Or you can just be thinking about, since it was negative 2 minus 4, circling your integers like so. Remember, if they're the same sign, when we combine our integers, we just add them up and we keep the sign. Now, another thing is, though, I can reduce this. So this actually becomes 2 over 3, which is similar to our last one, so we get a negative 2 over 3. The negative sign can be on the top or the bottom or just in front of the whole thing, if you wanted to do it that way. As I get rid of the negatives. Oops, it's not working. I can just put the negative sign in the front, or it can be on the top or the bottom. It just still means it's going to be a negative fraction there. So we have negative 2 over 3, which again, if we were going to change it, we could say negative 0.66 repeating, because that's also what that is. Here, same thing. I'm going to let you work this one out, and then I will walk you through it, make sure you've got the right answer. But I do want you to try this one on your own first. Okay, again, you should label what you have. So this is going to be x1, y1. This is going to be my x2, y2. If you did it backward, that's okay. If I did it backward, that's okay. You can do it backward as long as you keep your 2's together and your 1's together, so to speak. All right, so my formula, again, y2 minus y1 over x2 minus x1. My y2 is 2. My y1 is 5. My x2 is 6. My x1 is 3. Okay, when I do the math, 2 minus 5, again, if you're thinking about integers, think about money. I have $2, but I owe somebody $5. That means I still owe them $3. 6 minus 3 is 3. This one now I have a negative divided by a positive gives me a negative answer, excuse me. And a 3 divided by 3 gives me 1. So this is my final answer for this one here. You should have gotten negative 1. Okay, then we also have problems where we are given a table or a graph, and we now have to figure out the rate of change based on a particular graph. So this one is a weight change over the last 6 months. Now, there's a couple ways you're going to do this, but the best thing I would say is I need to give my months numbers. I'm not going to number them like the numbers like December is 12 and January is 1, all that. I'm going to say this is the first month, this is the second month, third month, fourth month, fifth month, sixth month, and seventh month, because it's like when we started, right? You know, if you were trying to lose weight or something. Now, from December, they're asking, I want to know what the change is from December, which is right here, all the way to June. So this is my rate of change. So now I need some ordered pairs. So I actually have to look at this graph and figure out what are my 2 sets of ordered pairs. Remember that this axis here on the bottom is which axis? If you said X, you're correct, because that's my X-axis. That makes this one here going vertical. Obviously, this one is my Y-axis. This is one of the first things you want to make sure you do so you have your correct ordered pair. All right, my first ordered pair is this one right here. So X is going to be 1, and my Y is going to be 150. Because I didn't go over 1, but this is 1. I'm not starting at 0 actually on this point down here. I'm starting at 1, which was December. Okay, now my second point right here is going to be 7 for my X because I'm going to the right 7. 1, 2, 3, 4, 5. Actually, I'm going over. We're going to count at 7 because we numbered this 7 because we didn't have a 0. Sorry. And then we're going up to this line right here. That's what is 125. Okay, so there's my 2 points that I needed. Again, I still need to do my y2 minus y1 over x2 minus x1. Okay, I'm going to pick the top one as my 1's and the bottom one is my y's. So this one is going to be my 1's, and I'm sorry, this one's going to be my 1's and this one's going to be my 2's, not my y's. All right, so let me rewrite this. I have y2 is 125 minus my y1 is 150. Then I have my x2 is 7 minus my x1, which is 1. Okay, when I do this math, I get negative 25 over 6. Now this is what we were looking for. If you think about it, it tells me right here in the problem the last 6 months. So my denominator has to be 6. And that's what I was getting at with the numbering it of 1 through 7. And that's why it became 7 minus 1. If you didn't want to do that, you just knew it was, I mean, we know it's 6 months. We could have just used that as my change in X, and we just wouldn't have anything necessarily written right here. Okay, I'm sorry. I keep getting interrupted, and I forget where I am. I think I'm telling you that I could have just put the 7 minus 1 as 6 and just left it like that, because, again, I know that was the weight change over 6 months. Okay, so that is our answer for this. But, again, we can actually divide that out to get a decimal answer for our rate of change, which would wind up being negative 4.16 repeating. Or you might round it and say negative 4.17, and this would have been fine too. But again, that one can be as a decimal answer because it is the rate of change for the weight loss. Okay, here's one for you to do. I would like you, this is talking about heart rate during aerobics class. So I want you to tell me the rate of change, excuse me, from 5 minutes to 10 minutes. So go ahead and work that out and put your answer on for Edmodo. Or Educanon, sorry. Okay, same thing applies. I need to find out my order pairs. So my first order pair, again, remember my bottom axis here. This is going to be my x-axis. The vertical one here is going to be my y-axis. So I'm going to make my order pairs here. I've got 5 and 80. That's my first one. My second one is 10 and 100. Okay, so I'm going to use my same formula, y2 minus y1 over x2 minus x1. When I put that out, I get my y2 is 100 minus 80, and then my y1 is 10. No, I'm sorry, excuse me, my x2 is 10, and my x1 is 5. Okay, so I have 20. 100 minus 80 is 20 over 5. When I do the division there, it gives me an answer of 4. Now that makes sense too because this is a positive slope, and so it's a change. My rate of change is 4. Okay, so that's our information about rate of change. Remember, again, we do need to memorize this formula here. This is one of our big things we need to make sure we know. And then also remember to think about your x and your y. If you want to just number it as 1 and 2, this is my x1, y1. This is my x2, y2. As I was learning it, I used to like writing it more with the x2, y2 above or below, as I did here in blue, rather than just the numbers like this. This didn't really help me too much. I had to write it more like this in order to make sure that I was putting it in the correct spot over here to make sure I had my y2 where it went, my y1 where it went. So figure out what works best for you. Also, don't forget to look at things like the slope of the line to begin with. We know that this slope here, that is a positive slope. We know that if it was this is going to be a negative slope. So keep those types of things in mind. It would help you to see if your answer is supposed to be positive or negative. Remember that a negative divided by a positive, whether it's on top or bottom, is still going to be a negative answer. If we have 2 negatives, remember that's going to be a positive answer. So you want to watch that too when you're doing your graphing or when you're looking at the graph versus the answer you got when they give you a graph. For ones that they don't give you a graph, like some of the other ones we did, you could certainly graph those on a piece of graph paper and just to check your answers to see if you were correct. All right, have a great night and see everybody next class.